Hello everyone, and welcome to another episode of BMED 202. In this episode, we will be looking at solving for reaction forces for a simply supported beam, and this is part 2 of the last episode. In this episode, we will be looking at a simply supported beam with 2-point loads being applied. And as you can see the image, the 2-point loads of 3 kilonewtons and 5 kilonewtons respectively are being applied. And for this exercise, I'll use R1 as my pivot point, or the point that I'm going to take moments from. So let's begin. Now, as was stated in the previous video, the sum of upward forces are equal to the sum of downward forces, and this applies for a beam that is in equilibrium, meaning there's no failure taking place. So the sum of upward forces are R1 and R2. The sum of downward forces are the 3 kilonewton force and the 5 kilonewton force. When you add those forces, you'll get 8 kilonewtons. So that's the sum of downward forces, 8 kilonewtons. But we don't know what R1 and R2 are individually. We just know that R1 plus R2 is equal to 8 kilonewtons based on the first formula. Then you have the second formula. This is the sum of clockwise moments is equal to the sum of the anti-clockwise moments. Now, if you're taking moments from the pivot point R1, you would not consider R1 as the moments, because R1 would be 0. So the other moments that are left to consider is the moments at 3 kilonewtons, the moments at 5 kilonewtons, and the moments at R2 from the pivot point. So the 3 kilonewton moment is clockwise based on the direction. The 5 kilonewtons will also give a clockwise moment, and the R2 force, the reaction force, will give an anti-clockwise moment. So when you find the moments of the 3 kilonewton force and the 5 kilonewton force, it should be equal to the moments that you find at R2. And here's another formula to bear in mind. When you add the moments of the first two forces, which are the downward forces, once you add R2 to those forces, the moments should be 0, because the anti-clockwise direction will result in the R2 being subtracted rather than multiplied, rather than added, rather. So let's go ahead with the formula. So here are the 3 moments. This is what I was talking about. 3 times 4, that's the first moment. 5 times 7, that's the second moment. And R2 times 12, because R2 is at a distance of 12 meters from R1, which is the pivot point. So if you notice, the R2 is negative because the rotation is anti-clockwise. Let's go to the next step. So we realize that the moments at 3 kilonewtons based on the distance is 12 kilonewton meters. And the second moment is 5 times 7, that is equal to 35 kilonewton meters. And all of that will be, you will subtract the moments of R2. So let's go to the next formula, or the next row in the calculations. So the 12 kilonewton force meters and the 35 kilonewton meters moments, both of them are moments, they will be added. But what I've done first of all is to bring over R2 times 12 to the other side of the equation, so that the minus sign is converted to a positive sign. Then in the next row, I will add the moments, and you will get the sum of clockwise moments, because the 3 kilonewton force and the 5 kilonewton force, they are both producing clockwise moments. So when you find those moments, which are 12 and 35 respectively, and they are added, you get the sum of clockwise moments. And over the next side of the equation, you get the sum of the anti-clockwise moments, which is R2 times 12. That's the only clockwise moment, R2 times 12. Then, since you have the formula like this, you want to make R2 the subject. So since R2 is being multiplied by 12, in order to make it the subject, you have to transfer the 12 over to the other side of the equation, to the left side of the equation. By doing so, the 12, the multiplication sign before the 12 will now become a division sign. So the next line will look like this. And once you have divided 47 by 12, you will arrive at your answer, and the answer will be 3.91 kilonewtons. Then the next line, since you know that the sum of upward forces will be equal to the sum of downward forces, you can apply this equation. And once you work it out and make R1 the subject, you'll arrive at your answer. And that answer will be 8 kilonewtons minus 3.91 kilonewtons, which will be 4.09 kilonewtons. Right? Let me show you something very interesting. This can be very simple, and this applies for every simply supported beam, regardless of the number of forces that are applied. All you have to do is find the sum of all the upward moments. So that would be 12 times 35. If you had 5 forces, all you would have to do is find the moments of all 5 forces and add them. Once you add them, all you would have to do is divide it by the length of the beam, which would be 12. As you can see here, in order to find the moments of R2, you'll have to find the entire length of the beam. The entire length of the beam is the measurement you'll use to find the moments of R2. So all you have to do, find the sum of all the moments of downward forces, divide it by the length of the beam, which is the distance of R2 from R1, and you will arrive at the answer. That is pretty simple. But for the sake of showing the working, we have to do all these steps to arrive at the sum of all the downward moments divided by the length of the beam, which is the distance of R2, because as we have here, this is the moments for R2 times 12. But once we bring it across, we get a division sign. So this is the sum of all the moments that are acting on the beam, the downward moments. So if we had 5 forces, we would find all the moments of the 5 forces. It would be here, and it will be divided by the length of the beam. This is the case for a simply supported beam. Now let's change the pivot point, and let's show you how this would work out. So this time the pivot point is on the right, R2. So we would need to find R1 first. So if you notice, all the moments are here. Now the 5 kilonewtons is a minus moment, a negative moment, because it's now anti-clockwise. Then the 3 kilonewtons is the same. So let's continue. R1 in this case would be positive. So if we are to work out the moments, we'll have 25 minus 24. That's negative 25 minus negative 24. And in order for the signs to be positive, we will take the 25 and the 24 kilonewtons and bring them across for them to be positive. In the next line, you'll have this, the addition of all the moments. Then, as was explained before, divide the sum of all the moments that are acting down by the length of the beam, and you'll arrive at the answer. So in this case, R1 is 4.09. That's the answer we got there when we use the other pivot point. And then once you work out the formula, you'll arrive at R2. And that is basically it. That is basically how we calculate the reaction forces for a simply supported beam when there are more than 1 point loads being applied. This principle can be applied if there are 3 point loads. All you have to do is find the moments of the 3 point loads, then add them together. I hope you learned. I hope this lesson was informative and you grasped the concept that was taught. Please have a good day. Don't forget to subscribe and like the page. See you all soon.